Okay, good morning, everyone. Welcome to Math 101, our last session for the week. Ang bilis ng panahon, no? No look now, it's already a Thursday, almost the weekend. Today, let's try to finish the study guide for week number 4, and hopefully we can also start with week number 5. Having said that, postpone muna natin yung submission ng worksheet number 5. So siguro, kailan kaya? Um, Siguro, let's try to push it until siguro Saturday at around 12 noon next week. Let me just take note of that. So worksheet 5, gawin nating due on, supposedly that would be due on Monday, the 18th, pero gawin nating 23rd at around 12 noon. Okay, pero pagka nakita nyo yung problem sa worksheet number 5 and we have tackled that already, so you can start doing it. You can ask help from your lab instructors on Monday. Pero para lang ma-justify na natapos natin or na-discuss natin lahat ng coverage niya, let's postpone the submission to the 23rd. So, yeah. But simulan nyo na kagad para hindi kayo matambakan kasi possibly if we can finish a substantial part of worksheet or of the study guide for week 6 next week, then probably ikikip natin yung deadline ng worksheet 6 on the 25th. All right? So try nyo na siyang simulan try nyo na siyang simulan and then ask your lab instructors for help. But yeah, let's push the deadline to Saturday next week para para na-cover na natin siya in the lecture lahat. Okay? Now today we'll begin with this nice quote from Hardy. He said that a mathematician, like a painter or poet, is a maker of patterns. Okay? Kaya kung makikita nyo, hindi tayo masyadong nagdadwell na sa mga specific examples. We're trying to start establishing a pattern that will hold for as many elements of the domain or of the universe we're talking about. Because again, the job of mathematicians is not just to compute certain things or to compute for specific scenarios. We would like to extrapolate the pattern, and then out of these patterns, we would like to create lasting theorems. Because as Hardy said, if his patterns are more permanent than theirs, it is because they are made with ideas. So hindi naluluma yung mathematical ideas, hindi naluluma yung mathematical proofs. You will see that we are still studying proofs coming from the 1600s, from the 1800s, and sometimes it even goes to the pre-modern times. Like there are still proofs, say, developed before Christ na hanggang ngayon pinag-aaralan pa rin natin because these are patterns, generic patterns that withstood the test of time, and the reason is they are made with ideas, with logical implications or with strong logical foundations. Kaya naman hanggang ngayon pinag-aaralan pa rin natin sila. Okay? So probably para ma-inspire kayo to remain in the program, probably from time to time I'll start with nice quotes like this. Okay, before starting the business of the day. So for today, papagpatuloy natin yung proof of existence. Kukunti na lang naman yung natitira. So last time, kinonsider natin yung how to prove statements involving more than one quantifier, nauna yung for all or nauna yung there exists. So today we'll look at certain existence theorems that do not claim just the existence of something, but also the uniqueness of such an element. So let's start with illustration 20. So dito ang sabi, prove that there exists a unique real number x such that ln x equals 2. Now, this is not just the existence theorem that, it is not like the existence theorems that we have considered so far, kasi meron tong additional claim. it is claiming the existence of a unique. So ibig sabihin, meron nag-exist tapos ito ay nag-iisa lamang. Hindi katulad dati na existence lang, hindi natin alam kung ilan. So illustration 20 is more powerful in the sense na kaya niyo sabihin na may nag-exist na unique. Okay. So that means we are really proving two things, sir, here. Number one is the existence. At sabi natin kung existence lang naman siya, let's forget about the uniqueness first. Ang base lang dun sa theorem, there exists a real number x. So since the claim is that there is a real number x such that ln x equals 2, pwede nating i-construct yung solution ng ln x equals 2. Kasi nga, ang gusto lang nating sabihin ay may nag-exist for the first part of our proof. So you can start your proof by your PA. So we want to find x in R such that the following equation is true. ln x equals 2, right? And then, of course, since we are starting here in the PA, equal silang dalawa, so equal yung number na makukuha ko kung gagamitin ko silang parehas exponent ng same base. And here I use the base E. Ang kagandahan ng pagkuha ng base E followed by an ln will sort of cancel each other out kasi inverses sila ng isa't isa, leaving us with an x on the left-hand side and E squared on the right. So here we have seen a value of x satisfying the equation ln x equals 2, and that is E squared. So pwede natin itong gamitin sa proof of existence. So pwede nyo lagyan dito QEF. Pero medyo sinauna na itong QEF, quod erat faciendum. Ibig sabihin, we have constructed what was to be constructed. Or we have created what is supposed to be created. In particular, we have created a real number x, or we have discovered a real number x such that x equals E squared. Okay? Now, so that's what the first half of the proof does here. So, binigay niya kung ano yung particular value of x, constructive proof yung ginamit niya. And then, the next step is to verify that indeed x equals E squared will satisfy the given equation. So, or you can even be more particular about it, lagyan nyo ng element of R. Kasi sabi, unique real number. So, and then sinubstitute niya yung E squared dun sa ln x, sa karoon ng ln E squared, simplify, hanggang nakarating siya sa 2. Therefore, we have proven that E squared satisfies ln x equals 2. But we won't stop there because the theorem is saying na may nag-exist pero unique siya. So we have found one such example. So existence is done. So we go to the next part, or the next half, which is proving the uniqueness. And the classic way of showing uniqueness is to assume na merong dalawa and show that they are equal to each other. Okay? So pwede natin gawin dito. So suppose there exists a number y, okay, not equal to E squared. Or pwedeng wag nyo nang lagay ito. So there exists a y in R. Kasi proof by contradiction pero hindi pa natin na-discuss. So let me do it the direct way. So I'm going to suppose there exists another y in R such that ln y is equal to 2. Okay? So i-assume ko na may nag-exist pa na isang real number such that ln y is equal to 2. And I want to show that this value y should be equal to E squared, thus proving the uniqueness. Kasi sabi ko nga dito, suppose meron pang nag-exist na y. Pero pag napakita ko na yung y na to dapat equal sa E squared, then I have proven the uniqueness. Okay? So, inassume ko ng ln y ay equal kay 2. Pero we have shown that 2 is, here, where is that? 2 is equal to ln of E squared. Okay. So, ibig sabihin, pwede kong palitan yung 2 dito sa equation na to by ln of E squared. Okay. Tapos, alam natin si logarithm, si natural log, ay isang one-to-one function, right? Since it's a one-to-one function, then if I have equal ln's, then their arguments must be equal to each other. So hopefully you remember that from algebra. So this means that y is equal to e squared since the function f of x equals ln x is 1 to 1. Okay. And this proves uniqueness, so therefore there exists a unique. By the way, the symbol or our symbol for the existence of a unique element is the usual existence quantifier. Just lagyan nyo ng exclamation point. So these two symbols next to each other means there exists a unique. So there exists a unique x such that ln of x is equal to 2. Kasi kung may mag-exist pa na isa pang real number, ng ln niya ay 2, napakita natin yung y na yon ay dapat e squared din, which is basically what we have constructed earlier. Okay, so here that ends the proof of uniqueness. Okay, so in summary, if you have a statement claiming the existence of a unique element, first prove the existence, and then second prove the uniqueness following this method. Okay, ito yung usual method pagpapakita na unique, right? So let's try another example. This is exercise 21. For every integer n, there exists a unique integer m such that 2m plus 8n equals 6. So, okay. So as I've said, the first part is to prove existence. Now it is claiming that there exists a unique m. So forget about the uniqueness first. We want to prove the existence of an integer m such that 2m plus 8n is equal to 6. Now, first question of the day. Ano kaya yung m? By the way, yung theorem nga pala for every n. So ibig sabihin, given si n, tapos kailangan maghanap ka ng m which might depend on n. Alright, so kasi yung pagkaka-state ng theorem, for every integer n. So pag binigyan ka daw ng integer n, ano yung may mahanap ka na m such that 2m plus 8n is equal to 6. Now, this choice of m, hindi kailangan mag-hold siya sa lahat ng integers n. Kailangan lamang, pag binigyan ka ng specific n, may maibigay ka ng specific m. So you can think of n to be the challenge. So bibigyan kita ng n. Ang challenge sa'yo, maghanap ng response m such that 2m plus 8n is equal to 6. So this m might depend on n because of the way the theorem was stated. Hindi naman sinabing there exists an integer m for all integer n. Nauna yung pagsasabi ng for all integer. Sa bawat isang integer n, may mahahanap ka na m. So given muna si n, maghahanap tayo ng m. And that m might depend on the value of n. Right? So what should be the value of m for a given integer n? So I will start here given an integer n. So we take m equals what? Kita ko nagtaas si John Rensis. You wanna try, John Rensis? Sorry, siya yung nauna eh. Nakita ko nagtaas na siya ng kamay. Or pass mo na, John.
Wait lang. M is equals to 3 plus 4n.
3 plus 4n. Okay. So, paano mo ito nakuha dyan? Nag-PA ka mula rito? Tama ba?
Sir, minus 4n po pala.
Okay. Actually, hindi ko pa rin na-check kasi maaga pa, right? So, mabagal pang mag-process. Pero anyway, let's see. Nagsosolve tayo ng m. So, ibig sabihin, 2m equals 6 minus 8n. Divide both sides by 2. So, we get 3 minus 4n. Yun yung PA. Okay, thank you, Rensis. So, that's right. So, we take m equals 3 minus 4n. And because n is an integer, 4n will become an integer. 3 minus 4n is, of course, an integer as well. So, pwede nyo ilagay element din ni z. Mahalaga na sabihin nyo na yung 3 minus 4n ay element ni z. Kasi ang claim, there exists a unique integer. So we're looking for an integer m. So kaya kailangan nyo itong sabihin. I might give you some deductions if you forgot to say that 3 minus 4n is an integer. Okay? So kasi ang hinahanap ko ay integer, kailangan integer yung ibigay nyo. But again, it's easy to see because 4n is an integer, 3 is an integer. The difference of two integers is yet another integer. Okay? So nakapagbigay na tayo ng m. So what's left to be done is to show that this satisfies the equation. So note that 2m plus 8n will then become 2 times 3 minus 4n plus 8n equals 6. Sorry, hindi ko pa sure na equals siya kay 6. Simplify, so we'll have 6 minus 8n plus 8n equals kay 6. Right? So this shows that indeed the choice of m that we have specified earlier actually satisfies the equation 2m plus 8n equals 6 for the given value of n. So we are done with existence. Now we prove uniqueness. So we suppose there exists a p in n, in z. Kunwari, meron pang isang integer aside from m that satisfies the equation for the given value of n. So suppose tawagin natin siyang p. So such that 2p plus 8n is equal to 6. So parang sinabi natin, kunwari, meron pang nag-exist na isang element ni z na nakakasatisfy nito aside from this value of m that we have given. All right? Now, pakita natin si m dapat equal kay p. Now again, the trick here is dahil equal to kay 6, pero napakita natin equal din kay 6 yung 2m plus 8n. Therefore, yung 2p plus 8n dapat equal siya kay 2m plus 8n, where m is our choice earlier, right? And here, we can subtract 8n from both sides. So we get 2p equals 2m. Divide both sides by 2, so we get p equals m. And therefore, kung may mag-exist pa na isang integer such that this equation is true, that integer p must be equal to the value of m that we have established earlier. So that means we have indeed proven the uniqueness, all right? So thus, there exists a unique m in z such that 2m plus 8n is equal to 6, end of proof. Or pwedeng, kung medyo classical kayo, QED yung gawin, yung gamitin yung marker sa end ng proof, which means quod erat demonstrandum, which was to be shown. Right? Napakita na natin kung ano yung kailangang ipakita. Right? Okay, is that clear? Any questions? Before we proceed to the next one. Hold on, guys. Give me a second here. Okay, so the next two results that we will be proving are sort of universally quantified, pero in the form na sila ng isang conditional statement. So kung matatandaan nyo dati, nung nagta-translate tayo from English to symbolic, parang kapag ka merong for all o merong universal quantifier, mukhang ang laging gamit natin, nagiging conditional sila. Alright? Because conditional statements are meant to be used in a generic fashion or in a universal fashion na basta na-satisfy niya yung antecedent, magpa-follow kagad si consequent. So if you're dealing with a universally quantified conditional statement, so mangyayari lang ay gusto nating ipakita na yung conditional statement na yun ay totoo para sa lahat ng elements ng domain. So what we'll do is get the antecedent, assume the antecedent, right? And then show that the conclusion or the consequent follows. So kung meron tayong for all x, p of x implies q of x, all right? So gagawin natin, pipili, i-assume natin yung antecedent. So i-assume natin na P of x is true for all x in the domain. Then we want to use logical arguments in order to arrive at Q of x for a generic x. Siguro, pagka inassume natin na totoo yung antecedent P about all elements of the domain, mag-consider ka ng isang element ng domain. Okay. So, laging nagiging part ng premise yung precedent o yung antecedent. So, mag-consider ka ng isang arbitrary ng domain. Gamitin mo yung statement P about X, which holds for all elements of the domain, and use logical arguments in order to come up with the conclusion Q of X for the generic X that we have chosen earlier. So, ganun yung maging atake natin para sa mga conditional statements. So, let's illustrate it via example 23 here. So, we want to prove that for all real numbers R and S, if R and S are rational numbers, then R plus S is a rational number. So, ang domain natin dito ay real numbers, pero may additional assumption. R and S must be rational numbers. So actually, we can go ahead, because ito naman yung magiging premise natin, we can go ahead assuming R and S are rational numbers or coming from the set of rational numbers. You can even think of the domain to be Q from the get-go, right? Kasi yung antecedent naman ang gagamitin natin as a premise. So our premise is, or our assumption in the proof is that R and S are rational numbers. And then we want to show the consequent is true. Gusto nating ipakita na si R plus S ay isang rational number. Right? So I can start the proof this way. So write proof. So I'll consider R and S to be generic rational numbers. Right? Kasi universal statement to. For all real numbers na rationals then at the same time. Pero kapag ka rational automatic na real number, so pwedeng mag-take na lang ako ng dalawang generic element ni Q. Kasi yun lang naman yung concern ng antecedent, right? So kung si R at saka si S ay rational number, we want to show that R plus S is rational. So I'm beginning here with two rational numbers R and S. Then dahil generic sila, ano yung distinguishing characteristic ng rational numbers? So what can we say about R and S? Anyone? Yes, Mary Rose.
Hello po, sir.
Hi.
Sir, po,
Go ahead.
our rational numbers po can be written as a ratio of two numbers. So, we can suppose po na there exists an integer A, B, C, and D.
Great. Such that our R and S can be written as a ratio of these integers, right?
Opo.
Okay, thank you, Mary Rose. That's perfect. So there will exist integers A, B, C, and D, but such that R is A over B and S equals C over D, but we have the added restriction that B and D are non-zero, right? Kasi hindi pwede mag-zero yung denominator. So ito yung distinguishing characteristic ng mga rationals. So any generic rational number can be written as a ratio of two integers. Okay? So ang restriction lang dapat yung denominator sa hindi mag-zero. So this is a nice characterization. We are keeping the generality of our choice of rational numbers. Wala tayong ibang inimpose kasi alam natin totoo to sa lahat ng rationals. A, B, C, and D are generic integers that will correspond to the generic R and S that we have chosen. And now what we want to show is that R plus S is a rational number. Kaya siguro na-suggest ni Mary Rose na ganito ito yung gamiting distinguishing characteristic ng rationals. Kasi in the end, I want to take a look at how R plus S looks like. So probably we can say here, note that R plus S can be expanded as A over B plus C over D, right? Because we have found a nice specification for the form of R and S respectively. So yung R plus S, pwede kong masulat this way. And then usual addition of fractions, I can write this as AD plus BC all over BD. But we know neither B nor D is equal to 0. So ibig sabihin dito yung BD ay hindi 0. And then BD and AD plus BC are integers, being the product and sum of products of integers respectively. Okay? So alam natin yung AD plus BC at saka yung BD ay integers, and then si BD ay hindi 0. So it looks like R plus S is indeed a rational number because we have written it as a ratio of two integers, the denominator being non-zero. Okay, so you can say thus R plus S is a rational number. Okay, and that ends the proof. Kasi nakarating na tayo dun sa consequent na hinahanap natin coming from the antecedent. Okay? Alright, so mukhang madali lang, no? Tama ba? Sana ganito lang yung mga ipapaprove, no? Okay, probably let's try another one. And I think this is the last example for the study guide for week 4. So exercise 26. So we are here defining a different relation na na-encounter niyo na ba tong symbol na to? A bar B read as A divides B. Or hindi pa?
Hindi pa po ako, sir.
Okay, so right, no problem. So let's talk about it a little bit. So kapag given ka ng dalawang integers, A and B, we say that A divides B if and only if, so masasabi natin tong relation na to ay totoo if B can be written as a multiple of A. A times say P for some P in R. Sorry, for some integer P. Hindi R kasi laging magiging totoo yan. So, masasabi natin na A divides B if and only if B can be written as a multiple of A. Pwede nating isulat si B as an integer times A. Or in other words, we can say that A is a divisor or is a factor of B. Medyo ito yung fancy way ng saying na si A ay isang factor ni B. So we say A divides B. And this is true if we can write B as a multiple of A. All right. So clear ba? Halimbawa, 2 divides 4 because 4 can be written as 2 times 2. 3 divides 27 because 3 is a factor of 27. In fact, 27 can be written as 9 times 3, right? So our multiplier, integer multiplier here is 9. But 5 does not divide 21. Kasi si 21, hindi natin kayang isulat as 5 times some integer. Dapat yung multiplier dun sa A ay integer dapat, right? So 5 times 4 is 20, 5 times 5 is 25, naligtangan si 21. So we say 5 doesn't divide 21. Or in other words, 5 is not a factor of 21. Okay? So yun lang yung gustong sabihin ng divides relation. Okay? So is that okay? Clear na sa atin kung ibig sabihin ng divides? Ibig sabihin lang factor siya. Okay? Thank you. So let's go to the thing that we want to prove. So we want to prove that for all integers A, B, C, if A divides B and B divides C, so these two guys are the antecedent kasi nandun pa sila sa if part. So ito yung premises natin. Ibig sabihin, pwede natin siyang i-assume dun sa theorem kasi sila yung condition na mag-trigger para dun sa conclusion, right? So kaya sa proof, kailangan nating or pwede nating i-assume or gagamitin talaga natin sila in order to come up with the conclusion. Because again, you can think of the premises as the triggers so that the conclusion follows. So we will assume that A divides B and B divides C para mapakita na true yung consequent that A divides C. Okay? So ito yung ating conclusion. Okay, so we can begin the proof by saying that we consider integers A, B, and C such that I'll use the premises now. A divides B and B divides C. Okay. Now, generic C, A, B, C, but there's an additional condition coming from the premise that A divides B and B equals C. So if I have this, then what can I say about B? Anyone? Okay, go Kelvin.
Hello, parinig po ba?
Oh yes, yeah.
Sir, pwede po nating masabi na yung A is a factor of B. So, B is equal to any integer M times A.
Okay, thank you. Though I need to correct it a little bit, Kelvin. Hindi for all M. Dapat there exists an M.
Apa.
Kasi, yeah, hindi natin siya kayang, hindi siya pwede mag-hold sa lahat ng integers. Kailangan lang merong isa. Alright? But I see your point here. And how about the other? I think I saw Gad raise his hand. So, ano naman si C? Magagaling dun sa B divide C.
Pwede naman po natin ilagay na ano po. N times B po.
Okay, thank you, Gad. That's right. So I can say that N times B, and again, for some integers M and N, right? These two equations will be true for some specific M and N, guaranteed by the definition of the divides relation, okay? And then here we want to show that B divides C, okay? So paano ko to masusula? Sorry, A divides C. So ano yung gusto nating ipakita? Pwede nyo itong ilagay sa scratch paper para ma-analyze nyo ano yung susunod na part ng proof. So gusto kong ipakita si A divides C. I think somebody's raising their hand. Marnie, may suggestion kang gagawin next?
Hello po. So, gusto pong ipakita na A divides C. So, ibig sabihin po nun, dapat A po is a divisor or factor of C. So, thus, since yung B po since C po is, how do I say this? Pwede po natin gawing C is equal to NB nga po, gaya po namin dun sa taas. Then, equal din po siya sa N times M times A since B is equal to MA. Tapos, pwede po natin gamitin yung commutative property. So, pwede po maging NM times A.
Okay, thank you, Marnie. Tinapos mo na yung proof for me. Thank you. So yeah, before going to Marnie's suggestion, I was about to say ano yung gusto natin ipakita para guided tayo kung ano yung magiging susunod na step, paano naisip ni Marnie na ganito yung gawin, right? So remember, we want to show that A divides C. So by definition, dapat si C daw ay masulat mo as a product of A with another integer. So say P for some P in Z. So that means in order to come up with A divides C, kailangan makahanap tayo ng integer P such that PA is equal to C. And I guess that is what Marnie saw here, na yung P pwedeng gawin nating N times M. Kasi ang P times A, where P is N times M, is equal to A. Alright? So that would be the completion of the proof here. Sinulat ko lang to para alam natin yung gusto nating ipakita. Pero you don't need to include it in the proof. So you can go ahead and saying na, so from these two equations we have seen above, C can be written as N times B, but instead of B, I'm going to use M times A, which is basically through the associative property of multiplication. This can be written as NM times A, where Mn is an integer, okay? Kasi being product of two integers. And here we can say that indeed A divides C by definition. End of proof. Okay? So dun sa mga BS math students dyan, saka MST, you will be seeing the divides relation more and more pagdating nyo sa Math 103, which is number theory. Mga ganito yung mga kailangan nyo improve. So it will pay if you get familiar with it. Siguro sa mga exercises natin in the future, we will see divides again. All right. Okay, and I think that's it. That's module 4. Tama ba? Yes, I think so. So any questions with the types of proofs that we have encountered today? Pero don't get too excited. Meron pa namang 14 minutes. So yeah. Pwede pa mag-start ng worksheet 5. Okay. Na-announce ko ba yung correction about worksheet 5 last time? Announce ko ba sa inyo?
Yes, sir.
Okay. Thank you. So please take note of that. Yun nga ba yung pwede kong gamitin? Here. Okay. Okay. Now, the next type of proof is proof by contraposition. And the proof by contraposition is basically, again, a proof of a conditional statement. So yung statement natin dito na gustong i-prove can be written as P implying Q. Kaya lang, there are some instances na yung mahirap ipakita yung conclusion coming from the antecedent. Okay? Especially if we cannot find a nice formula or a nice specification for the statement P. So medyo mahirap ipakita na magfa-follow si Q. Now, if that is the case, you can try to prove the contrapositive because according to our rules of equivalence, and I think it was called transposition in the work text, pwede natin kunin yung contrapositive ng P implying Q, which is equivalent to the original statement via the rule transposition. Okay? So, tandaan nyo ba, ano yung pag nag-apply ako ng transposition, anong kakalabasan from P implying Q? Yes, Mary Mitzi?
Ano po, yung equivalent po ng contraposition ay not Q implies not P.
Okay, thank you. That's correct. So kung mahirap i-prove yung P implying Q, pwede pala nating i-try na i-prove na lamang yung not Q implying not P. So magiging part ng ating assumption or ang i-assume natin na premise dun sa proof ay not Q. And if we will be able to show that not P is true, then we have proven the original statement. Kasi nga equivalent lang naman silang dalawa. Or this biconditional statement is a tautology. Diba? Alam na natin yan from rules of equivalences. So again, here's another tool or skill that you can add to your repertoire. Pag mahirap i-prove yung P implying Q, i-try nyo yung not Q implying not P. Baka madaling ipakita na kapag ka hindi totoo si Q, magpa-follow na hindi totoo si P. And that is equivalent to P implying Q, so you're done pag napakita mo yung not Q implying not P. Okay? So let's try to look at an example here. Okay. So sabi sa illustration 27, for all integers n, if n squared is even, then n is even. Okay. So ang P natin dito ay n squared is even. Tapos ang Q natin na conclusion ay n is even. Okay? So you can try to do a direct proof. Okay? So proof. So we will let n be an integer such that n squared is even. I think we use a double struct E para sa even numbers, right? Tapos we want to show that n follows to be even. Okay, so ang assumption natin, n squared si even. Kung even si n squared. So kung even si n squared, ano yung characteristic niya? Then n squared can be written as twice another integer, right? For some integer p. Okay? Kaya lang gusto kong makita ano yung itsura ni n. Well, you can take the square root of both sides. Maging n equals plus or minus square root of 2p. Okay? But we have a problem here. So, hindi natin alam, actually, hindi nga natin alam kung ito ay integer pa rin. Alright? Ang gusto nating ipakita si n ay twice some integer. Okay? But here, stuck na ako. Pwede ko itong isulat as plus or minus, or pwede ko itong isulat as square root of 2 times plus or minus square root of p. Kaya lang ang gusto natin mapakita, 2 times some integer siya. And you see the difficulty of this approach. Parang stuck na ako. So, hindi ko na, dahil si n, ito lang yung nakuha ko mula dun sa premise, hindi ko makonclude na si n ay pwedeng isulat as twice some integer. Kasi galing dun sa premise, ang napakita ko lang siya ay equals sa square root of 2 times plus or minus square root of some integer. And that is not enough in order to show that n is twice some integer. So kaya problematic yung direct proof. Parang wala tayong maaabot by using the direct proof. Now, if that is the case, then it might be helpful to try to prove the contrapositive instead. Now, the contrapositive is kailangan lang natin itong i-translate into not Q implying not P. And what is that translation in words? Anyone? Yes, Emerson?
If n is odd, then n squared is also odd.
Okay, great. Thank you. Double struck. Oo nga lang pala yun. All right. So that's the contrapositive. Kasi kailangan nating not Q, siya yung magiging bagong premise. N is even. So ang bago nating premise is n is not even. That means n is odd. And then what we want to show is that not n squared is even, meaning n squared must be odd. And that is what is done in the vortex. So let's read the proof. So nag-consider siya ng integer. And then, para mas madali dun sa magbabasa ng proof, baka kasi ma-lost siya na, ang premise dun sa theorem may n squared is even, but may inassume na si n ay odd. So maybe it's nice to indicate that you're doing a proof by contraposition. So you can say contrapositively, though parang medyo odd yung pagkakagamit ng term. Pero pwede nyo sabihin na doing a proof by contraposition, we can suppose that n is not even. That is, n is odd. And since n is odd, we can write n as 2k plus 1 for some integer k. All right? So dahil si n ay equal kay 2k plus 1, we want to probe whether n squared is odd or even. Or we want to look at the property of n squared. Mas madali yung contrapositive kasi meron tayong mas specific na expression para kay n. So pag si n ay odd, pwede natin siyang isulat as 2k plus 1. And if we will square that to get n squared, we will get 4k squared plus 4k plus 1. We can isolate the plus 1 and group the first two terms. But the first two terms, 4k squared plus 4k, is even. kaya nating mag-factor ng 2 mula sa 4k squared plus 4k. So we can write it this way. And so what we have found out here is that n squared is twice some integer, 2k squared plus 2k plus 1, making it odd. All right? And what we have shown here is kung odd si n, then n squared is also odd, which is basically, as Emerson pointed out, is the contraposition of the original statement. And the contrapositive of a statement is equivalent to the original statement. So with this, we can consider the original statement proven. Okay? Is that good? All right? So nakita niyo kung bakit mahirap yung mahirap i-prove siya directly using proving the statement P implying Q. Kasi ang hirap tumawid mula sa n square papunta sa n kasi nagkaroon tayo ng square root para dun sa form ni n. Pero mas madali na nagsimula kay n. But that will cost you doing transposition before proving the statement. Okay. So maybe we'll end with the exercise 28. Okay. Which is very similar to that example. Kaya lang dito ay okay. Try nga natin yung direct proof kung bakit siya mahirap. Sana mahirap nga siya. So kung direct proof yung gagamitan natin, mag-start tayo sa assumption na a squared minus 2n minus 2a plus 7 is even. Okay. And we want to show that a is odd. All right? So ibig sabihin, out of this, gusto kong makita kung ano yung itsura ni A. Alright? So, kung ito ay even, ibig sabihin ng a squared minus 2a plus 7 ay equals sa 2p for some integer p. Right? Yun yung magagaling dun sa premise. So this could be a first step in our direct proof. Kaya lang, ano yung susunod na step? Kaya lang kung isolve si A, ano yung itsura ni A? Pero madali ba siyang mahanap dito? Well, you can do a squared minus 2a plus 7 minus 2p equals 0. And again, we want to look at how a looks like. Ano yung itsura ni A? Kaya lang mula dito, mukhang kailangan ko mag-quadratic formula para makuha yung itsura ni A. So if you apply quadratic formula, we'll get what? 2 plus or minus square root of b squared minus 4 times AC all over 2a. All over 2. Okay? So ito yung itsura ni A pag sinolve natin using the quadratic formula. So here we can say this is equal to 1 plus or minus square root of 2 minus lalabas yung 4, 1 minus 7 minus 2p. Okay. Tama nga ba? Tama ba yung algebra ko? Maka-cancel yung 2 pero kailangan kong ilabas yung 4 para maging 2. Canceled yung 2's. May natirang 1, may natirang 1. I get this. Tama? Pero ang problema, gusto kong makita kung ito ay odd. Kaya lang ang problema ko ay, okay, nandun na yung 1, kaya yung plus 1, kaya lang hindi ko alam kung ito ay even. Dapat kasi ito maging 2k for some integer k. Kaya lang may square root na na-involved. So that will be a big problem, or that would be the problem if we will be attacking it directly. Okay? So that's why I will revert to try to use to prove the contrapositive instead. Okay? Tama ba yung algebra ko? Yung pala yung problema, kasi recorded yung meeting. So pag may nagawa akong mali, forever na siyang nasa internet. So hopefully tama yung algebra ko. Kung hindi man, edi sorry. Maaga pa kasi. Pero that's the gist, alright? Yes, Calvin?
Sir, may tanong lang po dun sa kasi di ba pwede naman pong mapakita na even yung nasa loob? Kasi po, di ba sinabi natin na even yung 2p.
Aha.
Tapos minus po siya sa 7. So, automatic po na 7 minus 2p is odd.
Okay, 7
Tapos,
minus p.
ay automatic na add po.
Aha, yes.
Tapos, yung 1 minus odd, ang ano naman po niya is even. Kasi odd minus odd.
So, ito ay magiging even.
Opo.
Kaya, anong square root ng even?
Ang square root po ng even ay even din.
Dahil, kasi ito yung pinrove natin kanina. Tama nga ba?
Opo. Opo.
Kapag kasi n squared ay even, dapat si n ay even din.
Opo. Tapos, even plus minus sa odd. So, odd po siya.
Okay, I think that's fine. Kaya lang ang problema ay hindi pa natin na-prove na ang actually pwede nga siya mag-work. 7.
Kasi po sir, di ba ang add ay 2a plus 1? So, kaya,
Yes.
opo, kaya po yun yung ano.
Yeah, yun yung ginamit mo dito, no? Sa odd minus even ay
Opo.
odd. Pero hindi pa natin siya na-prove sa klase. So, kailangan mo pa siyang isama dun sa proof. Hindi mo lang pwedeng sabihin na odd minus even ay odd. So, kailangan ipakita mo pa yung proof kung bakit yung odd minus even ay odd. Pero as you have mentioned, di naman siya mahirap, no? Kaya lang dagdag pa rin siya nasulatin. Right? At saka ang problema ay, kung nakalimutan mo yung theorem kanina na kapag ka si n squared ay even, dapat si n ay even din. So, or magagamit nga ba natin siya? So, napakita natin na ito ay even. Ito ay, yes. Ito ay even. So, kung siya ay even, ang square root ng even ay, so n squared is even. Or baligtad pala. Alam natin to ay even. Pwede nga gamitin, no? Tama, ang square root ng even ay even. Napakita natin kanina. So I guess you're right, Kelvin. Pwedeng mag-work yung direct proof as you suggested. So pwedeng ganon. Okay, so yeah, thank you for that suggestion. Though try natin din siya na contraposition kasi nandun siya sa section ng contraposition.
Sir,
And I think by contraposition is easier. Oh yes, Marnie.
ako po, Mitzi po.
Sorry, Mary. Mary Mitzi, go.
And question ko lang po, dun sa loob po ba ng radical, hindi po ba possible na mag-negative po yung value or mag-2? Which is yung square root po ng 2 is not rational po. So parang hindi pa rin po natin pwedeng, hindi pa rin po tayo sure na ganun yung magiging outcome.
Yeah, I think that's a good point, Mary. Yeah. Tama nga siya, Kelvin. So, magkakaroon ng butas yung proof natin. Kasi magkakaroon tayo dito in the end na negative 6 plus 2p. Tama ba? 2p minus 6. So, 1 minus 7, negative 6 plus 2p, right? So, kapag ka si p ay mas maliit sa 3, remember, p is an integer. So, pag si p ay mas maliit sa 3.
So, sir, dapat dun po siya isasama sa sa condition dun sa una or hindi po?
Hindi tayo pwedeng magdagdag ng condition kasi ang sabi lang dito, alam natin condition. Si a ay integer. Tapos, sinabi lang natin yung a squared minus 2a plus 7 ay equal kay 2p. Hindi natin alam kung ano si p. So, kung gusto mong ganun yung proof, then, kailangan mong tanggalin. Sabihin mo na hindi ito mag-work kapag ka si p ay mas maliit sa 3. Right? Kasi magkakaroon ka ng negative dito. O kaya kapag ka si negative 6 plus 2p ay equal kay 2. Kasi yung square root of 2, hindi siya magiging even. Alright? So, yun pala. Thank you, Mitzi. Nakitaan niyo ng butas yung iniisip natin na proof. So, hindi siya mag-hold sa lahat. Though, if you want to go about it, then siguro pwede kang gumawa ng separate proof para dun sa cases na hindi na-cover ng theorem mo. Nung proof na to. Kaya lang marami-rami pala yun, no? Kasi kailangan mong bantayan, dapat ito hindi mag-negative. Pero ito ay magne-negative sa lahat ng P na mas maliit kaysa kay 3. Tama nga ba? Yes, kasi kapag si P ay 2, negative 6 plus 4, negative square root ng negative ay imaginary. So hindi siya mag-hold pala. Okay? So thank you. So at least ngayon nag-iisip na kayo ng ng mga counter examples. Good job guys. Maraming ideas na lumalabas. So dahil merong mga komplikasyon yung iniisip nating direct proof, why not try a contrapositive proof? So let's try that. So okay, so we let A be an integer coming from the statement of the domain. Okay, then we'll assume that A is even. Kasi yun yung contrapositive, right? So ito yung P, ito yung Q. Pag gagawa ako ng proof by contraposition, I will assume not Q. So I will assume that it is not the case that A is odd. That means A is even. All right? Then since A is even, then there exists an integer P such that A equals twice P. Kasi even si A. So, yung A squared minus 2A plus 7 ay pwedeng masulat as 2P squared minus 2 times 2P plus 7. Okay? And this can be written as 4P squared minus 4P plus what? I can write it as 6 plus 1. Kasi ang gusto kong ipakita ay not P. That means A squared minus 2A plus 7 is odd. So, kailangan kong mapakita siya na 2K plus 1. Alright? Kaya nag-isolate na kagad ako ng plus 1. And then yung natitirang terms ay even. Kaya kong mag-factor out sa kanila ng 2. So I can write as 2 times P squared minus 4P minus 2P squared minus 2P plus 3 plus 1. All right. So since 2P squared minus 2P plus 3 is an integer, then we can conclude that A squared minus 2A plus 7 is odd. Okay. And this ends our proof. Okay. Sabi ko pala, mas okay kung ipapaalam natin dun sa magbabasa that we are doing a proof by contraposition. So pwede kong sabihin dito na or pwedeng lagyan nyo na lang ng parenthesis, contraposition yung gagamitin nyo. Or proof by contraposition. So proof parenthesis by contraposition. So again, we assume that A is even, and it will follow that A squared minus 2A plus 7 is odd. And so we have proven the contrapositive. The contrapositive is equivalent to the original statement. So we have proven example 28. All right? Okay, so that's another tool na pwedeng gamitin pag mahirap yung direct attack for the proof. All right? So any questions, guys? Let me see what's next. Okay, I guess there's a new method of proof coming up, and we'll do that on Tuesday. Okay, any questions before we go? Check ko lang yung chat. Oh, thank you, Victor. Kinaldan niya rin pala yung attention ko about the number 2. Okay, thank you, Victor, for that observation. Sorry sa late ako nagbasa ng chat. Any other questions? Concerns? Wala naman. By the way, a reminder, problem set 1.1 is, or the deadline is approaching. It would be on the 27th. And then malapit na pala tayong mag-problem set 1. We'll keep the date for problem set 1. So check nyo na lang yung sa syllabus natin o dun sa course guide kung kailan yung problem set 1. We will maintain the schedule, pero yung coverage niya ay siguro kung ano yung matatapos natin next week. All right? Kasi tandaan nyo ba, kailan yung date na yun? Check ko na lang, tapos sabihan ko kayo next week kasi time na. Alright, any other concerns? So if there are none, so those who recited today verbally, please put a comment on the meeting chat. I'll take care of yours, Gad. Okay. For the others, please put a comment. Yung worksheet 5, siguro deadline na lang siya ay sa Saturday. Not this Saturday, but Saturday after next. So anong date na yun? Saturday. Gawin nating 23. So worksheet 5 will be due on the 23rd. Pero simulan nyo na guys kasi pwede nyo na, or I think kaya nyo na sagutan yung problem number 1. Okay. Try nyo na siyang simulan para hindi tumambak. Kasi baka may deadline tayo sa 23, tapos meron ulit tayong deadline sa 25, sa Monday na yon. Okay? Tapos may problem set pa pala, no? So, try nyo na sagutan yung number 1. Mau-cover natin sa Tuesday yung number 2. And probably number 3 as well. So, yeah. Para lang merong extra time for you to do the proof. So gawin na natin siya on, yung deadline is sa 23 ng worksheet 5. But try to start doing after we discuss things. Try nyo na siyang simulan. And then if you have some difficulties with problem number 1, or if you have questions about something that we have already discussed, you can bring them up to your lab instructors on Monday para matulungan nila kayo. But you will not discuss new things on the labs on Monday. Okay? So if there are no other concerns, then thank you guys for getting up early today and joining me in this discussion. I enjoyed our discussion today. Hopefully you did as well. So enjoy the rest of the day, and then have a good weekend kasi last na meeting na natin this week. So let's see each other again on Tuesday. Bye everyone and keep safe.
Bye, sir.
Thank you,
Ingat
sir.
po.
Bye, sir.
Thank you
Thank
po,
you,
sir.
sir.